You might think 100 meters sounds like a long distance. No, for a modern car, this is incredibly short. You should know that. If you took apart the traditional fuel car in your garage and pulled out all the wires and connected them together, the total length would be up to 3 kilometers. This is equivalent to the height of 6 Taipei 101 buildings stacked together. And the weight is as high as 60 kilograms, which is like always carrying an adult in the car, slashing it from 3 kilometers to just 100 meters. Where did that missing 97% of wiring go? This isn't just about saving a few kilograms of copper. This is Tesla, setting a massive stage to achieve fully automated production. Today, we are going to deconstruct this invisible revolution by Tesla and why the Cybertruck's 48-volt system will make traditional automakers feel a deep sense of despair. First, we have to figure out why there are so many wires in a car in the first place. The design logic of traditional cars is actually a bit like stacking blocks. If you want to add a power window, fine, add a controller and pull a wire from the front to the door. If you want to add automatic wipers, add another set and pull another wire. Over the decades, as cars gained more and more features, the wiring inside became a terrifying mess of spaghetti. This structure is called a point-to-point connection. Almost every sensor and every light bulb has its own dedicated wiring leading back to the central computer. This creates two major problems. First, it's the weight. Carrying around 60 kilograms of copper is a waste of energy in itself. This is a fatal blow to the range of an electric vehicle. Second, and most frustrating for automakers, is the inability to automate. Imagine that wires are soft. They sagged and they wiggled. Current industrial robots find it very difficult to accurately grasp these flimsy things to thread them through. So, even today, even in the most advanced Toyota or Volkswagen factories, the process of installing wiring harnesses still relies on a lot of manual labor. Workers must crawl into narrow car shells to stuff these wires in one by one and tie them down. This is not only slow, but also very expensive. Tesla wanted to kill these wires from day one. On the early Model S and Model X, they were actually just like traditional car makers, with harness lengths of about 3 kilometers. But with the Model 3, Tesla went on a major diet, shortening the harness to 1.5 kilometers. And on the latest Cybertruck, the technology that excites all electrical engineers, the 48 volts architecture. Why does switching to 48 volts reduce wiring? Here we need to review a middle school physics formula. Power equals voltage times current, P equals 4. Traditional cars use 12 volts voltage. This is like using a thin straw to drink bubble tea. If there are more and more electronic devices in the car, and the required power gets larger and larger, with the voltage at only 12 volts, the current must become very large. What does a large current mean? It means you need very thick copper wires to prevent the wires from overheating and burning out. But on the Cybertruck, Tesla directly increased the voltage fourfold to 48 volts. With higher voltage, the current can be smaller. With smaller currents, the wires can be made very thin and light. This change alone reduced the amount of copper in the Cybertruck's harness by 70%. In addition to making the wires thinner, Tesla also changed the wiring logic. Previously, it was 1-to-1 wiring. Now Tesla has switched to using something like a computer network, Etherloop, combined with zone controllers. This is like the Wi-Fi or network cables in our homes. You don't need to pull a separate wire from the server room for your computer, and then another for your phone. Tesla's approach is to only pull one high-speed data line to the front left door controller, which then takes responsibility for directing window movement. In this way, where dozens of wires were originally needed, now only 1 or 2 are required. This is why Elon Musk dares to declare the 100-meter, an insane goal. At this point, you might ask, does saving this little bit of copper really make that much of a difference for a car costing millions? Actually, what Musk is saving is not copper money. He wants manufacturing speed. Remember how we said robots can't install flexible wires? When the wires become shorter and fewer, Tesla is even applying for patents to make the wiring harnesses rigid, or even print the circuits directly onto structural components. At this point, wires are no longer limp noodles. They are rigid boards like Lego pieces. This means robotic arms can directly pick up an entire circuit assembly and snap it into the car with a click, with no human intervention required. This is Tesla's ultimate ambition, to build a machine that can build itself. Once the harness problem is solved, the most difficult last mile of full automation in car assembly is cleared. This will bring extreme production efficiency and cost advantages. Most interestingly, after the Cybertruck was launched, Musk did something very mocking, yet very clever. He printed Tesla's 48 volts architecture engineering manual into a small booklet and sent it to Ford's CEO, Jim Farley, with a note saying, "Feel free to reference this. It'll be helpful to you." It looks like humiliating a competitor, but it's actually a clever opening strategy because the 48 volts component supply chain is not yet mature. If only Tesla uses it, parts would be expensive and hard to buy. Musk needs other car makers to join the 48 volts camp to grow the supply chain so that everyone's costs can be lowered from 3 kilometers to 100 meters. This seemingly boring wire length actually hides the secret of Tesla's evolution from a car design company to a top-tier manufacturing company. Alright, that's it for today's video. How many years do you think it will take for traditional car makers to catch up with this 48 volts revolution? Or will they continue to stick with 12 volts? Welcome to leave a comment below and tell me what you think. If you like this kind of hardcore science popularization, don't forget to like, subscribe, and turn on the notification bell.